Hello students, I am Sachitraka. Welcome to Class Physics. We are continuing current electricity. Chapter number 3, 12th Physics. Okay. So now we are continuing combination of resistors. Combination of resistors. So we have discussed the fundamentals of combination of resistors, resistors in series and resistors in parallel, and combining series and parallel, mixed grouping of resistors. So on the basis of combination of resistors, we have completed 2 lectures, part 1 and part 2, means to solve the numericals and combination of resistors. In part 1, we have discussed fundamental numericals to solve combination of resistors, means to find equivalent resistors. Okay. And of course, we have discussed how to find potential difference in series grouping of resistors, current in parallel combination of resistors. In part 2, we have discussed how to find equivalent resistance by applying potential method. How to find equivalent resistance in combination of resistors by applying potential method. In this lecture, we will discuss how to find equivalent resistance in infinite series of resistors. How to find equivalent resistance in infinite series of resistors. Okay. I have already represented a circuit, means a network of resistors R1, R2, R1, R2, R1, R2, R1, R2 up to infinity. So we have to find equivalent resistance between A and B. Equivalent resistance between A and B. Okay. So I have taken R1, R2. We may assign any value of resistance. Value of resistance 1 ohm, value of resistance R2 is 2 ohm, R1 is 1 ohm, and so on. But here I have not used any values, but I have used variables R1, R2. Okay. So I have used variables, means to know the method, how to find equivalent resistance, what is the method actually. Then we can assign any numerical values of which can be given in the question. Okay, let's start. We have to find equivalent resistance between A and B. A and B. Just observe the network. In this set, see, this is a set, this is a set, this is a set, this is a set, and so on up to infinity. In first set, 2 resistors R1, R2. In this set, again 2 resistors R1, R2. Again in this set, R1, R2, and again R1, R2. Means all the sets, set 1, set 2, set 3, set 4, and so on. All the sets are similar. Means the pattern is similar. The arrangement pattern of resistors are similar. Okay, these are sets up to infinite, means infinite sets are there. We have to find equivalent resistance. Okay, see, this is first set, this is first set, and these are also different sets up to infinity. Okay, these are also different sets up to infinity. Okay, let combination of all these resistors, let X. Okay, let X. So if we take resistance of all these sets, means except first set, just leave it and onwards, except first set onwards, let total resistance is X. Okay. Now how can we represent? Again we will start from A. This is the resistance R1. This is the resistance R2. Okay. And finally, this is terminal B. The first set is completed. And thereafter, all the sets left, all the sets combined to give equivalent resistance, which is X. Okay. Means up to infinity, infinite sets are there. Okay. Equivalent resistance of these infinite sets of resistors, let X. Okay. Then we combine the total resistance, which is X. Okay. Equivalent resistance of this infinite sets is X. So this is X. Okay. Now, equivalent resistance of infinite sets is X. We have to combine again two resistors, R1 and R2. Then what will be final equivalent resistance between A and B? What will be equivalent resistance between A and B? Just think. These are infinite sets. I am showing from here onwards there are infinite sets. So combination of infinite sets of resistors of resistance R1 and R2 is X. If we again add only one set with X, then the value will not change. Because X is equivalent resistance of infinite identical sets. Infinite identical sets. If a single set is combined with this equivalent resistance, which is equivalent resistance of infinite sets, then also resistance between A and B, equivalent resistance between A and B will also be X. See, for example, we have discussed earth is always considered to be at zero potential. Earth is always considered to be at zero potential. What it means? A body becomes charged if it either loses or gains electrons. Okay. If a body either loses or gains electrons, then the body is said to be charged. Means, again we have discussed, if a body loses electrons, then it has positive potential because the body has positive charge. If a body gains electrons, then the body has a negative charge. So due to negative charge, potential is negative. But earth is considered as taken to be at zero potential. It means whatever amount of charge given to the earth or taken away from earth, it makes no difference in electrical condition of earth. Suppose we do some electrons, we do supply some electrons to earth. Will it change the electrical condition? No. We are taking potential of earth is zero. Whatever amount of electrons are added or taken away from earth, then also potential maintained to be zero. Why? Because earth is a massive body. Okay. And also, where there is mass, there is charge, means electrons, protons. Okay. And all these charges are assumed to be combined to give zero resulting charge. Okay. Earth is ocean of charges. Okay. So how many number of electrons, how many number of protons, we can't count. If some electrons are added, will it change the electrical condition of earth? Okay. Suppose we are considering about ocean. If you take a mug of water or a bucket full of water from ocean, will it make the difference in water level of ocean? No. Or if you drain some buckets of water to ocean, will it appear to be changed the level of water? No. Because if small amount is added or taken away, it makes no difference. Okay. We may compare this concept here. Number of infinite sets are combined to give equivalent resistance X. Again, if we add two resistors, means one set with X, then also equivalent resistance is X. This is the concept. Now, again we will have equivalent circuit. Start from A. This resistance is R1. These two, R2 and X, are in parallel. Combine them. Then we reach at B. As we know, reciprocal of parallel group resistance is 1 by R1 plus 1 by R2, which will give us R1 plus R2 divided by R1 R2, and accordingly parallel group resistance is R1 R2 divided by R1 plus R2. Similarly, these two are in parallel, so equivalent resistance of these two resistors will be R2 into X, R1 R2, R2 into X divided by R2 plus X. Okay, now it is easier. Okay, now these two resistors, R1 and this one, total resistance between A and B. Then these two are in series. If you consider the flow of current, considering A is at high potential, B is at low potential, then conventional current flows from A to B. Current is not divided into any branch. So obviously these two are in series. Then total resistance in series group resistance. If two resistors are combined in series, then equivalent resistance in series is algebraic sum of resistors. Then total resistance is R1 plus R2X divided by R2 plus X. Okay. This is equivalent resistance between A and B, but what we have discussed, equivalent resistance between A and B is X, because equivalent resistance of infinite number of sets is X. We are adding only one set with X, then also equivalent resistance is X. This is found to be equivalent resistance, and equivalent resistance is X. Okay. Now we will solve for X. Now let's solve. X is equal to LCM R2 plus X. Then this is R1 into R2 plus X plus R2 into X. Okay. Then X is equal to R1 R2 plus R1X plus R2X divided by R2 plus X. Then cross multiply it, X into R2 or R2X, it will be look better, R2X plus X into X is X squared plus, is equal to R1 R2 plus R1X plus R2X. R2X get cancelled. Then we'll write here what we will get, X square minus R1X minus R1 R2 is equal to 0. X square minus R2X minus R1 R2 is equal to 0. Now this equation is in quadratic form. We have to find value of X. What is equivalent resistance? Okay. Then solving it, we will get X is equal to, it is in the form of X square plus Bx plus C is equal to 0. Now solving, X is equal to minus B, means minus into minus R1, X square plus Bx. In place of B, we have got minus R1. So minus B plus minus square root of B square. B square means minus R1 square B square means minus R1 square, B square minus 4A. Here A is 1 into X square, 4A into C. This is C, means 4 into, I'll write here. 1 into X square, R1 into X, R1 R2. Okay. X is equal to, solving the quadratic equation, minus B means minus R1 plus minus square root of B square. Here B is minus R1 square minus 4AC minus 4. A is 1. C is minus R1 R2. Okay. C is minus R1 R2. Right. Divided by 2A. Divided by 2A. A is 1, 2 into 1. Okay. Then X is equal to, this is plus R1 plus minus square root of minus R1 square means R1 square minus into minus plus 4 R1 R2 divided by 2. Okay. This is our result. Solving this quadratic form equation. X is equal to R1 plus minus square root of R1 square plus 4 R1 R2 whole divided by 2. This is our answer. Okay. If the values are given, suppose, okay, let's consider. Is it clear now? Will I erase it? I have already completed the total form, and this is final equivalent circuit or equivalent resistance is sum of these two, algebraic sum of these two. This is equivalent resistance. This is the form. Okay. Now I am erasing it. Okay. Fine. We have got our result. Now, different consideration. Suppose if R1 is equal to R, let R. If R1 is equal to R2 is equal to R, then what will be the result? Then X is equal to, in case of R1, R plus minus square root of R1 square, R square, plus 4 R1 into R2 means 4R square divided by 2. So X is equal to R plus minus square root of 5R square divided by 2. Okay. Then R square, bring it outside. X is equal to R plus minus R into root 5 divided by 2. And finally you will get R by 2 into 1 plus minus root 5. This is our answer. But see, root 5 is greater than 1. Root 5 is greater than 1. So what are the possible answers? Equivalent resistance, R equivalent is equal to X, that is equals to, it means R by 2 into 1 plus root 5 or R by 2 into 1 minus root 5. Okay, but root over 5 is greater than 1, so this will come in negative. Resistance is a scalar quantity. Okay, so resistance can be taken as negative, so this is not considered. So our final answer is X is equal to, in this case X is equal to R by 2 into 1 plus root 5. If R1 is equal to R2 is equal to R, then this will be our answer. Okay. Then some other possibilities. Is it completed? Okay. Fine. Will I erase it? 1, 2, 3. Okay. Suppose the values are given like this. If R1 is equal to, let 1 ohm. R2 is equal to 2 ohm. 1 ohm, 2 ohm, 1 ohm, 2 ohm, 1 ohm, 2 ohm, and so on. Then we will use this. X is equal to R1 plus minus we will take plus because resistance can never be negative. Square root of R1 square plus 4 R1 R2 whole divided by 2. Now solve it. R1 is 1 ohm plus square root of R1 square means 1 square plus 4 R1 is 1 R2 is 2 whole divided by 2 and X is equal to 1 plus square root of this is 4 plus 2 sorry 4 into 2 8 plus 1 9 by 9 root over of 9 okay whole divided by so this will come 1 plus 3 divided by 2 means 2 ohm is final answer. For y2 is 2 ohm. Okay. This is one part of, let's change this now. Okay. Let's add some other resistances. Now, I am taking some values of resistances. Okay. Here also, taking resistor, here also, taking resistor. Again, we will take identical values. Let this is 1 ohm, identical value. This is 1 ohm, this is 1 ohm, this is 2 ohm. Similarly, this is 1 ohm, okay. This is 1 ohm and this is 2 ohm. Similarly, this is 1 ohm, this is 1 ohm and this is 2 ohm. 1 ohm and 2 ohm up to infinity. Again you see identical sets 1, 1, 2, 1, 1, 2, 1, 1, 2, 1, 1, 2 up to infinity. Infinite number of sets again. Except first set. We are considering the sets. Number of sets means infinite number of sets. Again we have to find equivalent resistance between A and B. So now let again equivalent resistance of all these means except first set. All these resistors means infinite sets. Equivalent resistance of infinite sets is X. Again we are taking X. Then let's represent now what we will get. Okay. Let's take first set A. This is 1. This is B. This is also 1. Okay. This is 2 ohm. Then sum of infinite set means equivalent resistance of this infinite set is X. Again the similar form. 2 ohm and X in parallel, then we will get starting from A 1, 2 and X in parallel, 2 and X in parallel, so that will be 2X divided by 2 plus X, R1 R2 divided by R1 plus R2, and finally this is terminal B and this resistance is 1 ohm. Now all these resistors are in series. Since equivalent resistance of infinite sets is X, so equivalent resistance between A and B is also X. Because these are infinite sets, we are adding only one set with equivalent resistance of infinite sets. Okay. Then equivalent resistance between A and B is X. Then what is total resistance? 1 plus 2x1, 2 plus x plus 1. All these are in series, that is equals to X, equivalent resistance. Again equal to X. Now only to solve 1 plus 1, 2, plus 2x divided by 2 plus x is equal to x. LCM 2 plus x, then it will come 2 into 2 plus x plus 2x is equal to x. Okay. Then it will come 4 plus 2x plus 2x divided by 2 plus x is equal to x. Just see, 4 plus 4x is equal to, cross multiply it, 2x plus x square. Then solving it, x square minus 2x minus 4 is equal to 0. Again quadratic form. X square minus 2x, x square minus 2x minus 4 is 0. Now, solving it, x will be equals to minus b, means minus into minus 2, minus into minus 2, again plus minus, square root of b square, means minus 2 square, minus 4, a is 1, 1 into x square, 4 into 1, minus 4, 4 into 1, 4, 4a, c, c is minus 4, okay. Divided by 2, then x is equal to, this is 2, plus minus, this is 4, this is plus 16, so square root of 20, whole divided by 4. Now this is our answer. So finally we will get it taking positive, because the resistance can never be negative. Square root of 20 divided by 2. And equivalent resistance I am writing here. Equivalent resistance between A and B is 2 plus square root of 20 divided by 2. So R equivalent is 2. This is 5 into 4, 2 into root of 5 divided by 2. And equivalent resistance is 2 by 2 1 plus root 5. 1 plus root 5. So no need to take negative, because again root 5 is greater than 1. The resistance will come in negative. Resistance is in positive quantity. So we have taken plus. So sometimes the values may differ. This type of circuit, the values may differ. This is 1 2 1. This may be 2 2 4. This may be 4 4 8. So this may be 8 8 16. Then what can be done? Similar method, but a slight difference is there. See, these are number of sets, infinite number of sets, but the sets are not identical. The sets are not similar. In first set we are getting 1 ohm, 2 ohm, 1 ohm, 1 2 1. In second set 2 4 2. In third set 4 8 4. In fourth set 8 16 8. So just observe. If we multiply 2 in first set, 1 into 2 2 ohm, 2 into 2 4 ohm, 1 into 2 2 ohm. Again multiply 2 into 2 4 ohm, 4 into 2 8 ohm, 2 into 2 4 ohm. Again multiply 4 into 2 8 ohm, 4 into 2 8 ohm, 8 into 2 16 ohm. Thus multiple is 2. Thus in this case, equivalent resistance we should take 2x. Equivalent resistance is 2x, so this is 2x. This is 2x. 1 2 1, and this is 2x. So now this will 2x into 2 divided by 2x plus 2. Now bring it in series. Sum of all these resistors is equals to 2x. Sum of all these resistors means I am writing only here. You will solve it. 1 plus 2x into 2 means 4x divided by 2x plus 2 plus 1 is equal to 2x. Now solve for x. Now solve for x. Similar way, again quadratic equation you can do it, because we have already discussed two types of numericals. Thanks my dear children. Again I will meet you with beautiful concept how to analyze combination of resistors to find equivalent resistance. Thanks my dear children. Thanks.